Okay, so today we're going to be looking at probability. So if you would, we're going to write down the definition. It's called a permutation. Okay, so what a permutation is written in a couple of different forms. It can be written in where n is a number or a couple of different numbers. It can be, right, that's a little better off. Or you can have permutation of x, y, where x and y are two different numbers. Okay, so a permutation is an arrangement or listing in which order is important. Okay? So, for example, they write in your book, they say that 5 people are running for 2 different offices for like class treasurer, class president, and vice president. Okay, and so you would have a permutation where it would say permutation is 5, 3. Or you can have it this way, 5, P3. So what we do is we're trying to find the exact number of ways that we could list the people and the offices they're running for. So the way you do that is say, you 5 times the next number, which would be 4, times the next number, which would be 3. Because we're doing starting at 5, and then we're multiplying by 3 numbers. So that would be 20 times 3, which is equal to 60. So the permutation for 5, 3 would be 60. Okay? So if we were to do permutation of 6, 3, what would that look like, Justin? When we're doing the permutation, you start at 5, and then you're listing descending. So it'd be 5 times 4 times 3. Makes sense? Okay, so this one will be 6 times 5 times 4. What about? You've just chosen 3. So that's what your second value is. Okay? So that would be 30 times 4, which is equal to 120.
Does it have to be in descending order?
Yeah, you're choosing, you're actually replacing, it's the number of events taken at that many at a time. And so you're taking 6, and then you're taking 5, and then you're taking 4. So it has to be one after the other. Okay, so what would be if you had, how many ways can 6 swimmers be arranged if we were to do it's a 4-person team, so how many ways? Yes, Brady.
I'm confused. So like, when you're multiplying, like, I'm confused about the 6 and the 3. So you multiply P times 6.
Okay, so yeah, let's do this one. I'll explain with this one. With what you're doing is you have, say we have 6 swimmers. Okay, so that's our first thing. We have 6 objects, and so we're trying to find out how many ways we can arrange them. And so the first time, because order matters, we are taking 6 swimmers. And so let's say Brady is our first swimmer. How many different ways can we order people after Brady? So there's 6 different ways that Brady could be the first swimmer, and then somebody else could be a second swimmer, third swimmer. Does that make sense? So then you go to the next one, which there'd only be 5 ways if Justin was the second swimmer. So if we had Brady, then we could have swimmer 2, 3, 4, 5, 6. And then we could have Brady, swimmer 3, 4, 5, 6, 2. And so after you do that, this is just a simple way of figuring out how many ways we could arrange the swimmers that way. So you have 6 different ways, with Brady being the first swimmer. And then once you got to swimmer 2, there would only be 5 different ways you could arrange them. Yes.
The second number 4, is that saying how many numbers you're going to multiply all together? Or
That's the
what
different
number
ways you can
you're
arrange
going
them.
to?
Yeah.
Is that the number that you're going to from 6 to 4? Or is
You're
that
going from,
multiple?
it would be 6 times 5 times 4 times 3.
Okay.
That's how many things you're multiplying together.
So you do the number like before the 6 and the 4? Or like-
Yeah, you start at the 6, and then you multiply. If this had been a 3, it would be 6 times 5 times 4.
6 times 5 times 4?
Yeah, the 3 is the indication of how many different things you're multiplying together. Okay, so let's try another one.
So what would the answer be?
That would be 30 times 120 times 3 equals 360. Okay, so try this one out. So this is a simple way of figuring out something where order matters.
So we don't go like 12 times 11 times 10, right?
That's what you're doing. Yeah.
Okay.
Okay, so with this one, we would take 12, there's 12 different cases, and then we would take 11, and then we would take 10 more, okay? So that would be 121, correct? No, 132 times 10, that would equal 1,320. Raise your hand, you got that?
Whoa.
Sorry, Brady. Let's work one more, and then we're going to jump to simple probability, which is a lot more fun.
Oh, I was trying to go all the way to like 3.
Oh, yeah, I swapped it in.
Yeah.
You're just taking, this number indicates how many cases you're taking.
So just give me 2 numbers before 12.
Yes. Well, with this one, it would be 2 numbers, so it'd be 5 and 4, right?
Oh.
Okay? Let's not do that one, because I just explained it to you. Okay? Try that. And then we're going to move on to simple probability. Okay, so John, what would our orders, what would it look like being multiplied together?
6, 5, 4. 30 times 4.
What else we got to have?
3.
We're taking 5 cases.
2.
Times 3.
Oh, that's a big one.
So we have 30 times 12 times 2, which would equal 30 times 24, which equals 7. Brady got it right. Awesome. Okay. We're going to cover that more in a minute, but let's go to simple probability.